Okay, hopefully that coughing is over now, at least for a little while. What you're looking at right here is a sketch of the first probability that we were looking for. Again, these are on the notes that have all of the instructions. And then on this page, the second and the third probabilities that we were looking for. Those are sketches of those probabilities with the corresponding probability label. Okay, now the next question here is what square footage would fall in the highest 8% of square footage covered by a gallon of paint? Whoops, there should have been a question mark there. Shame on me. And then what about the lowest 13%? Okay. Now, in the questions that we just did, if you take a look at the diagrams, what we've done in the diagrams here is we've shown the cutoff points that we were given, and then we use the normal CDF function to determine that area under the curve. Now the questions that we're just asking here correspond to what are called normal percentiles. And in those cases, we know the area that we're interested in, but what we're trying to get is what cutoff gives us that. So the first question, we were looking for the highest 8%. So here's our normal curve. This is the mean is at 415. And we're looking for the cutoff for the largest 8%. So where that question mark is, somewhere out there, there's a split that gives us 0.08 to the right, and hence 0.92 to the left. Similarly, for the lowest 13%, that cutoff is going to be somewhere on the left half, and that left area is 0.13, and hence the right area is 0.87. And so we want to get those. Now, to get these, the function that we're going to use on the calculator, sorry, I know that I wrote this a little small, it's called the inverse normal function, or INV norm. Now, to get this, we're going to the same distribution menu that we did before, but this is a little bit different than based on the type of calculator that you're using. For those of you with the 83s and the 84s, the inverse norm should still be item 3 all the way through. For those of you who have an 89, when you click on the distribution menu, item 2 says inverse and it has a right arrow. So if you move down to that inverse menu and hit the right arrow, you will see a menu out to the right that starts out inverse normal, inverse t, and has a couple of other functions. But you want to choose that inverse normal function. So that's what I'm going to do here is I'm going to move down to 3 and hit enter. Okay. Now, with the inverse normal, there are 3 values that you have to put in. And you'll notice it says area, mu, and sigma. Mu and sigma, the same mu and sigma that we were talking about using in the case of the normal CDF. The important thing here is knowing the correct area to put in, and the area will always be the area to the left of the cutoff. So that's why I drew these pictures here. Again, in the case for the largest 8%, or the highest 8%, the appropriate area that we're going to put in is the area to the left of that cutoff. So we would put in 0.92. If we were looking for the lowest 8%, we'd put in 0.08. But we want the highest 8%, which is effectively saying the same thing as the lowest 92%. In this case, we wanted the lowest 13%, so we're going to put in 0.13. Okay, so our area for the highest 8%, we'll put in 0.08. Mu, that's 415. And the standard deviation was 17.3. Go down to paste, hit enter. And as you can see there, we've got 390.69. Remember, we're looking at the square footage here, so this is in the units of the variable. So anything 390, oh, you know what I just did? I just put in 0.08, and I meant to put in 0.92. Yeah, okay, well, I goofed. Let's go back and fix this.